technique for the separation and identification of gas phase ions. We all trust it to catch any terrorist attempting to pass an explosive through airport security. But sometimes we're the ones who are mistaken for the terrorist due to false positive alarms, or when the instrument says that there's an explosive present when there actually isn't. It's illustrated in the left column and is the product of using wide mobility detection windows, into which an interferent may fall and be mistaken for that explosive. This leads to loss of time and money and frustration on the part of the airline and the passenger, as resources are wasted trying to neutralize a non-existent threat. But we can't just arbitrarily shrink these windows, as in the center column. Otherwise, we risk excluding a true explosive peak, resulting in a false negative, and accidentally allowing that explosive through security, resulting in detonation and loss of life. So how do we solve this problem? Well, these windows are actually established by the accuracy of the mobility measurement referenced during calibration. So we'd be able to shrink these windows if the reference measurements were increased in accuracy from the current plus minus 2% to plus minus 0.2%. And I've done exactly just that. I've spent the last 3 years building an entirely new instrument, you can see in the top right, that accurately and precisely measures and controls all 5 variables that affect ion mobility. I'm now building a database of explosives of interest, including TNT and RDX, and in doing so, I'm also examining how different variables affect the mobilities of different ions to different degrees. For example, I've seen how increasing the atmospheric moisture content within the instrument decreases the mobility of RDX to a greater degree than TNT. So now, the impact of my research, there will be 2 immediate impacts of my research. First, higher reference accuracies will shrink these detection windows and will reduce false positives and prevent the loss of time and money. Secondly, because I'll know how those different variables affect mobility, we'll also be able to move that detection window to match field conditions. This will ensure that our false negative rate stays at 0% and we prevent the loss of life. And finally, my research also has the potential to have an even wider impact than just national security. To name just a few applications of IMS, the ability to have more accurate measurements would improve health screenings for cancer and other diseases, quality and assurance control in the pharmaceutical industry, and environmental monitoring both on Earth and on the International Space Station, all of which would help improve the health and safety of more than just airline passengers. Thank you.